28. And so we're down here. I should mention what's going on with the videos. I got kicked off of Dailymotion within a week. Canceled my account immediately. They won't explain it. They won't even let me find out why. And I think it's probably because of that LastPass video where I showed how to get the passwords out of LastPass, but I'm only guessing. They gave me no clue. So I had to go back to YouTube, but I had a separate YouTube account because they keep the, well, they don't seem to be any other alternative. But the thing is, they keep threatening to take down my YouTube channel for podcasts. So I made a separate one for the class videos, but that one is very limited right now until they go through some sort of ridiculous proving that I'm a real person. I can only put up 5 videos a day. So these videos are gone, and they won't be up for about a week. Anyway.
You better sell your own YouTube.
Yeah, well, I could just put them on my server where you have to download them, but then you wouldn't have all the features of YouTube. So I don't know. I may end up that way.
Platforms just hate you.
They do. They do. I used to have a lot of people trying to get me fired. I used to have businesses used to call the college all the time and demand that I get fired, and the press, and that hasn't happened in a couple of years, so it's good that I'm notorious again. I probably advertised some of my classes where they'd been banned. My classes were banned in Texas and stuff, so anyway, this one in particular, yeah.
I want to hear a story about that one. That's interesting. Like people called to get you fired?
Oh, absolutely. Several times. I forget why that original one happened where they, I found some medical data at the University of Louisiana Medical Center just hanging out on the web. So I told them, and they took it down, and their official statement said that a computer science professor from Central College San Francisco had hacked them and exposed their data, and that's why they had the breach. And they published that news article about that, and they called everybody to track me down and punish me for that. And I had to go through a bit of rigmarole to defend myself from that. A few of these things happened. I learned something. If you find a any kind of problem like that, you must report it directly to the feds. If you tell anybody else, you have no whistleblower protection. I should have had a lawyer right away. But I thought I would tell them, they'd take it down, and that would fix the problem. But that's not what you do.
You're too optimistic.
Yes, I just thought you'd take it down. I didn't think that they regarded it as valuable to blame me for it. And I also sent them the evidence right away that it had already leaked out a year ago, and there were copies of it all over the place, but they ignored that and said I was the breach. Anyway, things like that. Anyway, so let's get on with Android here. This class here is the one that got me banned in Texas. We found a vulnerability I was teaching at a college, and one of the students found a vulnerability in that college's app. So they tried to ban me and ban the whole course. Because most people, if you tell them there's a vulnerability in something, they just freak out. They say you're hacking them, you're a bad guy. That's what the administration down there did. But the students all said they would leave too, and so they forgave me. But anyway, I went to DEF CON and said, what's that?
Was it threatened to be banned, or is it actually still banned now, the course?
No, they reversed themselves after all the students said they would quit too. So, but you know, most authority figures, just ask the Catholic Church, and most authority figures, if you tell them something they don't want to hear, their answer is just shoot the messenger and the problem is solved. And it doesn't seem to matter where they are.
Crazy world.
Yeah, well, I think you have to understand the stress under which authority figures are. I understand it better as I get more experience. At first it seemed outrageous to me, now I'm sort of understanding how it happens. Because when you're an authority figure, a bunch of lunatics are bothering you all the time about crazy stuff. And it's too hard to tell which ones are real. Anyway, so we're down to this. We're going to talk about physical attacks through Polaris, memory corruption, just a variety more attacks you can do on Android, and there's more of this coming next time. So the first one, of course, is how do you get past a lock screen? If you get somebody's phone and it's locked, and you're supposed to put in the PIN, then the idea is nobody can get at your apps or anything without getting to the PIN, but that's not so much true at all. If USB debugging is turned on, then you can execute a command to release the lock screen there. But normally, in order to do this, you'd have to allow USB debugging, and this little box wants to pop up on the screen, and it can't do it because it's locked. So even if you try to activate USB debugging, it won't work. But there turn out to be some bugs. In early versions of Android, you could navigate to the emergency dialer, and then you would see the USB debugging authorization with the screen locked. So you would be able to click the button and approve it. All right, and so another one is you might want to run ADB as root. So when you get in, you have root privileges. This has gotten much more difficult to do. From Android 4.3 onward, you can't run ADB as root unless you put in a different ADB binary that is compiled with a flag. So you have to put in a custom version of ADB, and that's what our rooting application was doing, Magisk. Magisk put that in there, put in a different ADB binary, a ADB daemon binary on the device. And then there's unlocked bootloaders. This used to be all the rage. And people didn't like the Android operating system because it was pretty rudimentary, so they made alternative operating systems, and you could boot to this alternative operating system. And you can't do this with the emulators. You need real hardware that has a real recovery partition. You can reboot the whole thing into a different version of Android, custom version. And so you can unlock the bootloader. When you unlock the bootloader, it wipes all your user data. And this is the point. The idea is to make it secure. Now, if you find an iPhone and it's powered off, you can't use it, because if you turn it on, you'll need the iCloud password to do anything. You can pretty much just throw it away. And so that's the idea. Android tries to do the same thing, although it's much less effective.
iCloud is only for like updates.
No, if you don't have the iCloud password,
You can still, there's a procedure to get into the phone, bypass the initial passphrase.
you might be able, you don't get any of the previous person's data, though. Yeah, you might be able to use it as a phone. Yeah, but you can't.
In order to update
Yeah.
anything.
In order to update anything, yeah, but you won't be able to read their data, is the main thing, yeah. And that's the idea here. So you can unlock the bootloader and reinstall the OS, but when you do that, you lose all the user data, which is to protect the privacy of the user. So if the user unlocked the bootloader and left it that way because they're doing things like Clockwork Mod Recovery ROM, then you can get in with a root ADB shell, and then you can get the user data. So this is why, they don't recommend you doing this. And I don't know if anybody is doing this anymore. It was all the rage about 8 years ago to have an unlocked bootloader and put in an alternative operating system, but it's not that common anymore. Now, you can also use, if you have the disabled keyguard permission, then your app can remove the lock screen. See, can we lock the bootloader and remove root again after it's rooted? Yes, well, you certainly can undo Magisk. It's even an option there to uninstall Magisk and remove the binary. So you can undo rooting. I mean, all rooting is doing is adding some new files to the phone. So as far as I know, you can totally reverse it. Anyway, here's some code that will unlock the phone through an app. So in principle, it's possible for an app to unlock the phone, but it would have to have the disabled keyguard permission, and I'm not sure if any apps have that anymore. But I guess they, yeah.
With the lock Android phone, could you just go to like a reset the whole thing?
Well, I don't know.
Factory reset?
Well, I assume they have a factory reset. I know iPhones do. You can factory reset them in order to sell it. And I would assume Android has the same thing, but I'm not sure. It's a good question. Anyway, this one here, you can therefore make an app that has this permission and install it, and then you can bypass screen lock. And this is one thing Drozer could do. I'll demonstrate a couple. I've removed Drozer from this class because it seems to be kind of abandoned, but it had the ability to make malicious apps. And you could make an app that had disabled keyguard permission. So if you trick somebody into installing that app, then you could bypass the lock screen. Another thing you can do is you can just remove these files. The gesture.key is what has the pattern lock screen, and the password.key is what has pins and passwords. If you remove those files, then it will no longer have a lock screen at all. But you need root to remove those files, of course, so you've already have to be in. But anyway, it's a thing to know. Once you get in, you could remove those, and then the phone would never get locked again. All right, and there's an intent in early versions of Android that would unlock the phone from an ADB shell in any context, because it would just clear the task for the lock screen, and you did not have to provide the unlocking pattern to do that. So that's a bug. And like I say, that was a big news at the time. Think your Android phone is locked? Well, think again. And they say this bug was present, exposes any locking technique. It exists here. You are allowed to modify the type of lock mechanism, but when you do that, you ought to have to enter the previous unlock, but they forgot that. So you can change the lock mechanism to 0 without having the previous pin, so that kind of undoes the whole point. Although you would have to have a USB debugging turned on. There have only been a few devices sold with USB debugging turned on, but that's a serious security flaw if they are. Right, and then, of course, there's a bunch of these things. It used to be all over YouTube. Ways to get past the lock screen without any technology at all by just clicking on things. Because on the lock screen, there's a few things you could do, like an emergency call, receive an SMS, and people would just find a pattern of these activities that remove the lock screen. over and over again on different versions of the iPhone. So that's the thing. There are just ways to get there. For example, on Motorola Droid, you phone the device, answer the call, press back, and you're at the desktop. For Viber, you'd place a call, answer it, and then press the back button many times, and you're back to the desktop, this sort of thing. There were a bunch of these. And then you can bypass the lock screen if you have the user's Google credentials. This was by design, just like Microsoft now. If you get a Windows machine, they tell you to log into the Microsoft Cloud, and you can recover your password by going to the Microsoft Cloud, and you can copy your data to another machine. So they wanted Google's cloud services to be the backup. So you could go into like their Gmail account, connect to a linked Google account, and it would then unlock the phone. But they eliminated it after Android 4 because they decided it was too much of a weakness. And so now you can do it. You can bypass the lock screen from a Google account, but what it will do is erase all your data. So you can't steal anybody else's data this way. You'll get in the phone, but all your data will be gone, and you'll then have to install all your apps again. All right. And then there's remote attacks. So if you can get someone to install malware on the phone, install a malicious app like Drozer or the one we're going to make with Metasploit in the demos later, then of course they can you can now execute code on the machine. Now, if you put in a Drozer agent that has install packages, that can install more. And if you load a Drozer jar that has context, it can execute commands on this machine. So these are various ways to gain some degree of remote control over the Android phone. Then, of course, the most technical method, going all the way back to the classic exploits that we've had for decades, things like buffer overflow, print format vulnerabilities, and all that jazz, memory corruption vulnerabilities. In principle, there are some apps on the phone that are in fact compiled C and have these vulnerabilities, but these are pretty rare, not that common anymore. And there was one in Polaris, though. They had an Office and PDF file viewer, and the docx file had a stack-based buffer overflow, and that app had install packages permission, so you could exploit the overflow and force it to install another malicious app. And we talked about this one before. If your web views use JavaScript interface, then you can load code over the web and execute it. And so that was, again, the old versions of Android. Not that easy on modern versions. So you can use Metasploit too, which we'll use later. There's a add JavaScript interface exploit for this, but it will only be very powerful on the very old versions of Android. And so you go here, set the host, run have your module options. You can allow the browser to retry and so on, SSL, the usual stuff. You get a remote control to execute commands on the device, and if it is an old version of Android, you can execute Java commands on the operating system. All right. And here was another one. There's something called the Exynos driver, which had a memory corruption vulnerability. And so it was similar, and Drozer had one of these. So these things remind me of Dirty Cow, which was a very popular Linux attack a few years ago, or for that matter, Eternal Blue on Windows. Both of these sometimes give you complete control of the device and sometimes kill the device. There are quite a few of these that are dangerous, but they do sometimes give you root. So it's the same kind of thing. All right. Anyway, if you want to maintain access, then you're going to have an SU binary, and you can put in a minimal SU, which will actually elevate you to root without popping up a box to warn the user, which is much nicer, of course, for a bad guy that wants to maintain control. So you can include that in your malware if you like, and you need to if you want to keep a permanent presence on the phone. And then, of course, you can get in the middle. Boy, more typos every time. Anyway, so if you want to add code to a page that is not encrypted, you just have to get in the middle, and there are a bunch of ways to do it. You can just put up your own router and own the router, and then when people connect to your router you're in. This is what happens if you buy those Wi-Fi pineapples. You're the router. And the Wi-Fi pineapples just spoof whatever wireless networks are around them, so anybody that tries to connect, they're in fact connecting to the Wi-Fi pineapple, so you're in the middle. You can use ARP poisoning to redirect traffic on a local area network. You can use Burp, which is what we've been doing, and it will man them. It will. You have to redirect traffic to it, and then it will create the SSL certificates to fool people if they're willing to click through a warning that says there's something wrong with that SSL certificate, or if they're using an app that doesn't enforce it and doesn't pop up that warning, which a lot of them don't. So that's the thing, You could get a rogue certificate if you are very rich or a nation state, but you can just use it without that and target apps that don't bother to tell the user, of which there are plenty. So those are a few more exploits generally involving physical access to the device. Let's try a Kahoot. Eight B. All right. Yes, that's a good question. Are there exploits that kill it so you can never use it again? And there totally are. That's what Stuxnet did. Stuxnet permanently broke the uranium isotope separators. There were also ones that destroyed physical motors, and there are ones that destroy the hard drive, and there are ones that destroy your telephone account with a modem so you can't get in anymore by sending so much illegal stuff that the phone company will ban it. And I think there are a few others. There are ones that will alter the temperature control on the motherboard and on servers. There are quite a few of these physical destructive attacks. Yes, and that's the thing. People don't think about that when they're writing these things. That's the fundamental problem. The people writing these things are usually not aware of cyber attacks. They're like trying to build a motor for a power plant or something. And they're thinking about old-fashioned concerns like keeping it running and greased and stuff, and cyber is a million miles away. And the other thing is, once they build it, you use it for like 30 years. So they use standards that they build up with Windows 95 and old ideas. That's the problem. Anything to be secure in the cyber sense has to be updated like every few months. And there's a whole lot of infrastructure that people intend to just use for 20 years, and therefore it's going to be appalling towards the end of its lifetime. Of course, it's going to be using old versions of encryption and stuff. I mean, the rate of change of cyber is just way out of touch with the rate of change of a lot of infrastructure, like airplanes and stuff. And there's just one of the fundamental problems we have. It all comes from Moore's Law. Computers change much faster than any other kind of technology, and it sort of drives everybody nuts in different ways. Yeah, the question is, are they going to slow down? My entire life, everybody has always been saying, we've hit the end of Moore's Law, it's going to stop going so fast, and that has never happened. So I'm not expecting to ever see that. There's always a reason why it should stop, and somebody always finds a way to jump ahead again.
So I feel like innovation is moving slower now than it was like at the roots of the internet, or like well, actually I would come up with better.
Some people feel innovation's going slower. I don't know. I think the fundamental hardware just keep getting better. You just take a computer that's like 5 years old, and it's always been a piece of junk because the new one is so much better. So I don't know. I'm not convinced that anything has slowed down at all. And there's a lot of real exciting stuff right around the corner. Photonic computing, quantum computing and stuff is really coming. So there's no reason to expect it to stop taking giant leaps into high-powered stuff that will make everything we have now look like garbage. I don't see any sign of it hitting the end. Well, yeah, this is a common science fiction thing. I mean, do we keep expanding forever, or do we eventually reach like a plateau where we'd have a more stable society where things stop changing? It would be more peaceful, but more boring perhaps. That's the issue. That's the big thing in science fiction. Would you be happy in this utopia, or would you be bored and just start fighting among yourselves? It depends. Anyway, let's take a look at these. That's right, happy Halloween. All right. So, which one of these will delete all your data? Unlocking the bootloader will lose all your data. All right. All right, what permission allows an app to unlock the phone? Yep, disable key guard. Not a very descriptive name. All right, so what systems allow a website to unlock your phone? Android Device Manager, they say. Now, I don't think that's the same Android Device Manager we're seeing in Android Studio. But anyway, maybe it is. All right, which one of these is the most technical attack? For the memory corruption, the stuff we cover in 127, which we'll have again next semester, exploit development, where you really have to write your exploit in binary machine code and inject it. Considered the most technically demanding sort of attack. All right. Here we go. All right, so I've got the winners. Stop the recording. I can get to it.